This is part 3 of the Semester 2 final exam review. In Chapter 7, we talked about something called the double angle theorems. I mentioned them in the last video. The double angle theorem for sine is sine 2 theta equals 2 sine theta cosine theta. The double angle for cosine is cosine 2 theta is equal to cosine squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. For tangent 2 theta, we use a different formula than the one they gave. The one they gave in the book is more complicated, but if you remember that tangent is sine over cosine, then tangent 2 theta must be sine 2 theta over cosine 2 theta. So what if I tell you that angle theta is in quadrant 3, and the sine of theta is negative square root of 5 over 2. Find the cosine of 2 theta. Well, what you're going to do is you're going to start by drawing a triangle in quadrant 3. So in quadrant 3, this is going to be the hypotenuse, and this is how you finish your triangle. This is theta. The sine is negative square root of 5 over 2, so this is negative square root of 5, and this is 2. To find the cosine of 2 theta, one of our formulas, instead of having to solve for the side adjacent, one of our formulas was 1 minus 2 sine squared theta. So if instead of solving for the adjacent, I just used that. The way this works is, first I'm going to square negative square root of 5 over 2. Remember, you square a negative, you get a positive. So it's going to be positive 5 over 4. And then I'm going to multiply 2 times 5 over 4, which is going to be 5 over 2. And then 1 minus 5 over 2 is going to be negative 3 over 2. So the cosine of 2 theta is just negative 3 over the square over 2. Sometimes you do have to go and find the missing side in order to find the double angle theorem. So if I needed to find the other side, remember I just used the Pythagorean theorem. And I want you to notice what quadrant we're working in. The reason I mention that is because you need to remember that x is going to be negative. The reason x is going to be negative because in quadrant 3, both x and y are negative. Oh, this didn't work. Sorry, I was trying to make up a problem that would work, but this one apparently isn't going to work because you can't square root a negative. But that is in essence what you would do if you needed to find the other side. Just use the Pythagorean theorem. I'm going to erase that because clearly that wouldn't work. I should have noticed because the square root of 5 is bigger than 2, so maybe I should have made this 4, and then that would have worked out a little bit better here. Let's try that again. Sorry. If I make that 4, then that's going to be 16, and then that's going to be 1 minus 5 over 8, and then I'm going to get 3 over 8. There we go. There's my cosine of 2 theta. And then if I needed to go find the missing side, I would do x squared plus negative square root of 5 squared is equal to 4 squared. Now this will work because now the hypotenuse is bigger than the leg. Plus 5 is equal to 16, so x squared is equal to 11, so x is the square root of 11, but you need to make it negative if you wanted to use another formula. However, this one was set up, so you didn't have to find the missing side. This particular problem is not a formula that we actually covered in the book, although I think I probably should have. However, if you understand how the definition that we give you works, you'll be able to do the problem. We give you a definition for the sine of alpha plus beta if you know what the sine of alpha is and you know what the cosine of beta is. The way this works is, I know what sine of alpha is, so I'm going to plug in 3/4 here, and I'm going to plug in, oops, I didn't want the other one to be 3/4, I want the other one to be 1/3. Sorry. Alright, and then I would plug in 1/3 here. The problem is in the second half of the equation, I don't know what the cosine of alpha is or the sine of beta, but I can find it. So this is what I'm going to do. I'm going to draw a triangle here in quadrant 1. Actually, I'm not going to call it theta, I'm going to call that alpha. And we know the sine of alpha is 3 over 4. So to find the cosine of alpha, I need to find the side opposite using the Pythagorean theorem. You should probably figure out real fast that it's going to be the square root of 16 minus 9. So it's going to be the square root of 7. So this is 3/4 times 1/3 plus, now I know the cosine of alpha is going to be the square root of 7 over 4 times, now I need to find the sine of beta. I'm going to do the same thing, but this time I'm going to draw a different triangle and call this beta. Beta has a cosine of 1/3. I need to find the side opposite. Well, it's going to be the square root of 9 minus 1, which is going to be the square root of 8, or if you want to call it 2 square root of 2, that's fine. So the sine of beta is going to be 2 square root of 2 over 3. And then all I have to do to finish this problem off is multiply those fractions together and add that to the product of these two. And that's the final answer. You can write it like this, or you can write it like this. Either way is acceptable. When we were simplifying trigonometric expressions, we used our regular property of rational expressions. In order to add these two fractions, they don't have a common denominator. So I'm going to use our little trick for adding them, which is I'm going to multiply across this way and get 1 minus cosine theta plus 1 plus cosine theta. And when I multiply the denominators together, I want you to notice it's the a plus b, a minus b. That's important because when you multiply them together, you get a squared minus b squared. So now, when I go to simplify the numerator, these cancel and you're left with 2 over 1 minus cosine squared theta. But remember, 1 minus cosine squared theta, that's sine squared theta. And in order to simplify this into a single trig expression, we're going to write this as 2 cosecant squared theta, because 1 over sine squared theta is cosecant squared theta. And that's as simplified as we can get. Another thing we did in Chapter 7 was we solved basic trigonometric equations. And when we solved them, we left our answers in radians. So if you think about this like any other algebraic equation, think about it like wanting to get your like terms together. So in this problem, I would subtract 2 sine theta from both sides. So I'd be left with 2 sine theta plus 1 is equal to 0. And then I would subtract 1, divide by 2, and now I have a basic trigonometric equation. It says the sine of theta is equal to negative 1/2. Well, I want you to remember on the unit circle where all students take calculus, there are 2 places where the sign is going to be negative, quadrant 3 and quadrant 4. So I need to know the 2 angles whose sine is negative 1/2. Well, if you think about how your first quadrant works, it's pi over 6, which is 30 degrees. Cosine is square root of 3 over 2, and sine is 1/2. So I need something whose reference angle is pi over 6. Alright, so we have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This is 6 pi over 6. So this must be 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, and then 11 pi over 6. The reason I skipped over 10 pi over 6 is because that reduces to 5 pi over 3, which is not what I want. I want angles whose reference angle is pi over 6. Now, let's say you can't remember what the radian measures are. What you can do is you can do this in degree mode. And if you solve this in your calculator in degree mode, the calculator is going to tell you the answer is negative 30 degrees. That tells you right away that the reference angle is pi over 6. So if you're talking about a multiple choice problem, if any of your multiple choice answers are not some multiple of pi over 6, you know that can't be the right answer. And then you know that the angles you want to pick must be in quadrants 3 and 4. So remember that when taking a multiple choice test. Even if you can't remember how to find this, you probably can deduce the correct multiple choice answer. When we solve these trig equations, we're really probably going to just solve them for one round of the unit circle. We're not going to solve them for all answers. When we solve for all answers, that's the one where we plugged in the plus 2 pi k at the end of the answer. But we're just going to look at one rotation of the unit circle. So in this problem, cosine theta sine theta minus 2 cosine theta equals 0. Again, think about this like an algebra problem. If you think about this as x minus y minus 2x is equal to 0. This would be a problem where you would factor out the greatest common factor. Well, it turns out that both of those share a cosine theta. When you divide both of them by cosine theta, you're left with this. So now you're going to use the zero product property to finish the problem off. Well, this problem, when you solve it for sine theta, you get sine theta equals 2. Sine theta doesn't equal 2. Sine theta fluctuates between 1 and negative 1. So we can just ignore that part of the problem, which is kind of nice. Then I only have to worry about this problem. Well, where is the cosine of theta equal to 0? Well, one of the places it's 0 is at 90 degrees. And again, if you don't remember how to do it in radians, do it in your calculator in degrees. It'll tell you 90, and 90 is pi over 2. Well, it happens again at 270 degrees, which is 3 pi over 2. So the problem on the final, you may not necessarily be crossing this off, but you could. So you may get 2 answers, you may get 4 answers, but you'll have a problem on the final where you're going to have to factor out a greatest common factor. When we studied polar coordinates instead of x and y used r and theta. The way they worked was you would always start at your initial position just like you did with rectangular coordinates of the unit circle. And then you start with actually the angle measurement, even though that's the second coordinate. Pi over 6 says go counterclockwise 30 degrees, so you would go here. R stands for radius, so whatever your units of measurement, so the polar coordinate graph kind of looked like this. It was all these concentric circles. So this would be 1, and then this would be 2. So your point 2, pi over 6, would be right here. However, if I change that problem to be negative 2 pi over 6, you would still go pi over 6. But negative 2 means instead you go 180 degrees the other direction. If I change this problem to be 2 negative pi over 6, that just says start here at initial position and go clockwise pi over 6, and then go 2 out. But if I said to go negative 2 negative pi over 6, you would start by going in the counterclock or the clockwise direction, and then you would go backwards to 2. So in this problem, let's name 2 coterminal points of the polar coordinate 2, 3 pi over 4. Now, the way I'm going to attack this problem is I'm going to attack it by graphing it. So if the radius is 2, I'm going to draw 2 concentric circles. 3 pi over 4 is going to be right here. So we're going to go over to here and then 2 out, and that's our original point. So to find a coterminal point, like where would we be in the exact same location? One way of doing it is instead to go this direction, which means I would go negative pi over 4, because you need a reference angle that's the same. And then r would be negative 2 in order to go backwards this direction. So negative 2 negative pi over 4 would be a coterminal angle. Another way of doing this problem is to go all the way this direction. So if this is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, so that would be negative 5 pi over 4. So I could also go negative 5 pi over 4 and then go 2 out. And that would be another coterminal angle. There are other ways of doing this, but this is the most straightforward coterminal angles. We also talked about a relationship between polar and rectangular coordinates. If you want to go to polar from rectangular, the x coordinate is r cosine theta, and the y coordinate, I'm sorry, I shouldn't say to polar, sorry, this is from polar to rectangular. The y coordinate would be r sine theta, and these are two expressions that seem to pop up quite a bit when we talk about the rest of this chapter and when we talked about vectors, so keep that in mind. When we wanted to go from rectangular to polar, to find r squared was x squared plus y squared, which is just the Pythagorean theorem, and then tangent theta is y over x, which is actually a definition we have from trigonometry. So now let's try a problem where we're going to convert polar coordinates to rectangular coordinates. I want to convert 4 pi over 6 to rectangular coordinates. This is r, this is theta. So x is equal to r cosine theta. So that's 4 times the cosine of pi over 6. Pi over 6, which is 30 degrees, the cosine of 30 degrees is square root of 3 over 2. So the answer is going to be 2 square root of 3. The y-coordinate is r sine theta. So it's going to be 4 times the sine of 30 degrees. The sine of 30 degrees is 1/2. So y is going to be 2. So the rectangular coordinates are 2 radical 3 comma 2. Now let's try one where we convert rectangular coordinates to polar coordinates. So this is x and y. One of the things we said is that r squared is x squared plus y squared. So we're going to square this. We're going to square this. 3 to the square root of 3, when you square it, is 27. And negative 3 squared is 9. I just realized I did not have this going here. I'm going to repeat this real fast. R squared is x squared plus y squared, so I'm going to square 3 to the square root of 3. I'm going to square negative 9. 3 to the square root of 3 squared is 27. Negative 3 when I square it is 9. 27 plus 9 is 36, and remember that's r squared, so r is 6. To find the tangent of theta, which is y over x, I'm going to do negative 3 divided by 3 radical 3. You don't have to reduce it because you can just put this into your calculator, but if you reduce it, you get negative 1 over the square root of 3. If you're not sure what that is in radians, then you can always plug it in your calculator in degrees and do the inverse tangent of negative 1 divided by the square root of 3. And it'll tell you the answer is negative 30 degrees, which is negative pi over 6. Now here's the thing. On the final exam, they may not give you the answer as this. They may, instead of giving you negative pi over 6, they'll give you the answer between 0 and 2 pi, which is actually 11 pi over 6. So watch out for coterminal angles. The last thing that we did, at least in section 8.1, was we talked about writing an equation that's in rectangular form and polar form, and an equation that's in polar form and rectangular form. So if I ask you to write y equals 5, which is in rectangular form, into polar form, as long as you remember that y is equal to r sine theta, all you have to do is say that r sine theta is equal to 5. And that's all you have to do. That's the end of the problem. And then if I wanted to do a problem that was in polar form and write it in rectangular form, so I want to write r equals 7 in rectangular form, as long as you remember that r squared is equal to x squared plus y squared, what I can do is we can start by squaring both sides. As long as you do the same thing to both sides of the equation, remember it's the same equation. And then r squared is x squared plus y squared. And look, it's just the equation of a circle whose center is at the origin and whose radius is 7. And that's the end of part 3.